let's do this. So in our lesson today, we are going to have a deep, detailed, thorough, meticulous. Okay, what other synonym can I use? Fine, those are enough. So in short, we're going to have a deep discussion on the first 2 chapters of chemistry, Form 1. Now, this is a video that has been highly requested by my Form 1 students. So if you're watching this, let me tell you that by the end of this video, you should find it easy to score no less than a B in your CAT exams. So let's start. Now, these questions have been arranged according to the subtopics. So for example, over here we have introduction, drug abuse, apparatus, we have sources of heat, and so many more up to the end of the 2nd chapter. And there are plenty of application questions sprinkled inside. Now, these application questions are going to test your critical thinking skills. So it's going to be an exciting lesson. Now, one last thing, the total amount of questions that I have prepared for you are more than 50. Now, because this is going to take quite a lot of time, I'm going to divide this video into 2 parts. So once you're done with part 1, be sure to head to part 2. Define the term chemistry, okay? So chemistry is a branch of science that deals with the study of the structure, properties, and composition of matter and the changes that matter undergoes. Now, I want to say this. Sometimes for Form 1 students, it's a bit challenging remembering the structure, properties, and composition and not replacing it with any other term. So I have this for you, compost. So composition, properties, and lastly, structure. So you can simply change this and write compa. This is the study of the composition, the properties, and the structure of matter and the changes that matter undergoes, and you score yourself 1 mark. Question number 2. What is matter? Now, matter is anything that has mass and occupies space. State the 3 states of matter. This is where you have solids, liquids, and gases. Question number 3. Give 2 ways in which chemistry has helped improve the standards of living. Okay, so the question is simply asking you, how has chemistry improved the quality of life? You know, the resources that we have to ensure we can afford basic necessities such as food, shelter, clothing, etc. Now, chemistry has done so in several ways. Let me just mention a few of them. Manufacture of food to fight hunger, manufacture of medicines to fight diseases, manufacture of cheap fabrics such as nylon, manufacture of plastics, detergents, fuel, and so many more. So pick the ones that are easiest for you and stick with them. Question number 4. Give 3 career opportunities that are open to students who pursue chemistry. So the career opportunities include medicine, pharmacy, food technology, education, and engineering. So if you look at these careers, you'll note that there's an overlap between the careers that open up once you study biology and those that open up once you study chemistry. Moving on to our next subtopic, drug abuse. So our first question is whereby we are supposed to define the term drug. So a drug is any substance that can either be natural, it's found naturally, or it's manufactured, created, which when taken changes the way the body functions. Now, whenever we hear the term drug, we tend to associate it to the illegal drugs. But essentially, it could be anything, as long as it changes the way our body functions, is going to be considered as a drug under science. Now, I'm going to give you a very simple example. Pain relievers such as Panadol, these are actually considered to be drugs because don't they change the way your body functions? They do. So they are considered to be drugs. Not illegal, of course, and they are over the counter. You can simply go at a chemist and buy them, but scientifically, medically, they are still drugs. What is drug abuse? Now, this is whereby you're using the drugs for a purpose other than what it was intended for. Now, I'm going to give a very good example of the cough suppressants. So one of their side effects is that they make you feel dizzy and drowsy, and some people enjoy that because maybe it helps them to sleep better. So they take the cough suppressants not because they want to soothe their cough or reduce the irritation, but just because they want to sleep or they want that feeling of drowsiness. This is an example of drug abuse. Now, another aspect of drug abuse is whereby you're using the drug either more than what it was intended for or less of it. So overdosing or underdosing. So all of these are considered to be drug abuse. Give 2 drugs that are commonly abused: alcohol, mirror, tobacco, bang, yeah. List 3 harmful effects of drug abuse. So this is whereby you have hallucinations, depression, addiction, diseases like liver cirrhosis. Okay, let me go through them. Let's start with hallucinations. So hallucinations are sensory experiences that may seem real to the person who's under the effect of the drug, but are not. So they can involve any of the 5 senses: sight, hearing, touch, smell, even taste. Now, drugs cause hallucinations by interfering with the way our brain functions. So you can have some drugs causing people to see things that are not there. These are visual hallucinations, while others cause people to hear voices, auditory hallucinations. Depression. Now, depression is whereby you have this persistent feeling of sadness. Now, you'll find that with some people, drug use can actually cause them to become depressed. Now, if you have a person who's already depressed, it can actually cause the symptoms to become even worse. So how does the use of drugs cause depression? So it causes depression by altering or changing our brain chemistry. Okay, let me give an example. In our brain, we have a hormone called serotonin. This is known as the happy hormone. It causes you to become happy. It instills feelings of well-being in your body. You use certain drugs and they interfere with the level of serotonin. What do you think will happen next? Depression will set in. Now, another is addiction. Now, in our body, when you take a drug, what happens is that it stimulates the release of a hormone called dopamine. So dopamine is associated with pleasure and reward. Whenever you do something that makes you feel good, what happens is that you want to do it again and again, repeat the experience. So if you take a drug and it makes you feel good, your brain wants to have the experience again so that dopamine can be released. So the brain forms a strong association between the drug and pleasure. Over time, with repeated drug use, it leads to tolerance and addiction, whereby when you stop taking the drug, you have withdrawal symptoms. So the whole cycle of this represents addiction. And then the last one, diseases such as liver cirrhosis. Now, a good example of a drug that causes this disease is alcohol. So what happens is that in our body, the liver is the organ that is responsible for removal of poisonous substances. So when you take alcohol, it's taken down to the liver to be broken down into smaller molecules. Now, this process is highly toxic. It's poisonous and can cause the destruction of the cells within the liver. So, over time, with continuous use of alcohol, what will happen is that your cells are going to die. The cells that are there in the liver, and you're going to have healthy tissue replaced by damaged tissue. This causes a disease known as liver cirrhosis, and unfortunately, it's permanent. Moving on to question 6, Mr. Nyakundi went to a doctor who sent him to a pharmacy to pick some drugs. The pharmacist wrote on the medicine packaging 2x3. Clearly state what 2x3 meant. So this is a prescription. It's a written set of instructions that are given by a medical professional that give details on how to use a particular drug. So in this case, 2x3 simply states that Mr. Nyakundi is supposed to take 2 tablets 3 times a day. Now we have 24 hours in a day. So divide that by 3 gives you 8 hours. So every 8 hours, Mr. Nyakundi is supposed to take 2 tablets until the medicine is finished. State 2 reasons why it's important to adhere to doctor's prescription. So why are you supposed to follow the instructions of the doctor on how to take the drug? To prevent overdosing or underdosing. Question 7. The following are laboratory apparatus used in chemistry. Name them and give their uses. Okay, so the first one, that is the crucible. This is used when heating solid substances that require strong heating. The second one, that is the deflagrating spoon. It's used to hold substances being burned in gases. So you see this part? This covers the upper part of the gasture while the spoon goes within the gasture. So part B, give 2 reasons why most laboratory apparatus are made of glass. Now, glass apparatus don't react with most laboratory chemicals. So this makes them safe to use. Glass apparatus are also transparent, so you can easily see the observations. You can see the reaction that is taking place. And last one, glass apparatus can withstand high temperatures during heating. Question 8. Heating solids in a test tube or boiling tube is part of the task a learner is supposed to undertake in a given class experiment. Explain the 2 precautions a learner should observe. Okay, so the question is telling us that if a learner was to heat a solid in either a test tube or a boiling tube, in a class experiment, somewhere where there are going to be other students, what are the 2 precautions that the learner should observe? Number 1, you're supposed to hold the test tube or the boiling tube with a test tube holder when heating. This is the obvious one, so that you don't hurt yourself. Number 2, never ever let the open end of the test tube affect you or anybody else. Now, this is especially important because what happens is that when you're heating a liquid, it may spat out. And if it spats out, it may enter your eye or touch any part of your body. And remember, this is going to be hot, so it can end up causing injury. So always ensure that the open end faces away from you and anyone else. Explain the following. A boiling tube is usually more suitable for boiling liquids than a test tube. Now, this is a boiling tube, that is a test tube. The difference between the two is the width. The boiling point is wider than the test tube. Now, because it's wider, it's more suitable for boiling liquids, because when you boil liquids, there's a phenomenon that tends to occur, which is known as bumping. So the liquid can actually spat out, spat out of the tube. Now, if you have a boiling tube, it provides a wider surface. So you're going to have less likelihood of the liquid spatting out than when it comes to a test tube. Part B. A round bottomed flask is preferred for fractional distillation and not a flat bottomed flask. So that is a round bottom flask, that is a flat bottom flask. So as you can clearly see, it's all about the bottom. One is round, the other is flat. Now, the round bottom flask is preferred because it allows for even distribution of heat. Question number 8. The diagram below shows a commonly used apparatus in a chemistry lab. This is a Bunsen burner. So we already answered part A. And its function is that it's used as a source of heat in the lab. So for heating and such. Part B. State the uses of the parts labeled X and Y. Okay, let's first identify what X and Y are. So X is the chimney. This allows the laboratory gas, the fuel that is being used at that time, to mix with the air. Y is the collar. So this controls the amount of air that enters the chimney. Moving to question 9, define what a flame is. A flame is a mass of burning gases. Okay, what does this mean? Now, when you talk about a flame is formed when you have a substance burning in oxygen. So, for example, if you have fuel burning in oxygen, it's going to produce a flame. Now, what happens in such a case is that the substance burns in oxygen. Okay, there we have one of our gases, to produce products, which in most cases are going to be in gaseous state because of the very high temperatures that are present. So a flame is a mass, a collection of burning gases. So these burning gases produce light and heat, and that is what we observe. A Bunsen burner produces 2 types of flames. Name the 2 types of flames. We have the luminous flame, which is yellow in color, the non-luminous flame, which is blue in color. Now, how does the Bunsen burner produce 2 different types of flames? It all depends on the amount of oxygen, air, that is present. So there's a part of the Bunsen burner that is called the air hole. So essentially, this is a hole through which air passes into the Bunsen burner. Now, when the air hole is open, you're going to have air passing into the Bunsen burner, mixing with the laboratory gas, and then burning completely to produce a lot of heat. This, the flame that is produced from this type of burning is known as the non-luminous flame. Now, when the air hole is closed, no air enters into the Bunsen burner. So you're going to have burning taking place, combustion, yes, but it's going to be very little. So the burning that takes place is going to be incomplete because the amount of air that is present is little. Remember, for burning to take place, oxygen needs to be present. Now, because the oxygen that is present here is not enough, burning is complete. So it leads to the formation of a yellow flame that is known as the luminous flame. Question 10. Give any two differences between the two types of flames. Okay, so let's start with the luminous flame. This is a yellow flame. That is a blue flame. This flame is quiet while the non-luminous flame is quite noisy. The luminous flame is large and unsteady while the non-luminous flame is small and steady. Luminous flame has 4 regions while the non-luminous flame has 3 regions. And there you have the regions. Question number 11. Give 2 reasons why a luminous flame is not used for heating purposes. Okay, number 1 is that it produces less heat than the non-luminous flame. So if you're heating a substance using a luminous flame, it's going to take quite a longer time than with a non-luminous flame. And the second is that it produces soot. So it makes the glass apparatus or the laboratory apparatus to be dirty once used. So it's not preferable. Okay, moving on to our next question. A student from Masaibu High School lit a Bunsen burner and got the flame shown below. Okay, so we can clearly see that this is a flame that has 3 regions. Now the flame that has 3 regions is the non-luminous flame. So let's go through each part. So part A is the outermost region. This is the pale blue zone. Part B, the middle region. This is the green blue zone. And lastly, the innermost region, almost colorless zone. So the question is asking us, what is the color of the flame at the part labeled A? We've already answered that. Moving on to question 13. A wooden splint slipped through region B of the above flame. The splint was burnt as shown in the diagram below. Okay, so we have been told that they passed a wooden splint, by the way, that is a wooden splint, across the non-luminous flame. Now, if you look at this burnt part, you'll note that the outermost regions were burnt, but not the middle part. So explain why the splint was burnt the way it is shown in the diagram. So what I'm going to do is I'm going to explain this by using this diagram. Okay, then we'll come back to the question. Remember, I said this is thorough revision. Now, I want you to imagine you have 2 non-luminous flames and 2 wooden splints, of course. Now, you're going to take one of the wooden splints, pass it across the center of the non-luminous flame. What you're going to observe is this. So you're going to observe that the outer parts of the splint were burnt, those are the shaded parts, but the middle part was not. Now, coming back to the 3 regions of the non-luminous flame, we have the outermost pale blue zone. Now, in this zone, you're going to have the Bunsen burner gas coming into contact with air from the surrounding. So there is going to be complete combustion, complete burning. When you talk about burning, we are simply talking about a substance reacting with oxygen in the atmosphere. Now, if you have enough oxygen, if you have enough air, burning is going to be complete. But if the air that is present is insufficient, it's not enough, burning will still take place, but it's not going to be complete. So in this case, what happens is that you're going to have the Bunsen burner gas undergoing complete burning. Why? Because there is plenty of air at this point. Now, this is what you are seeing as the shaded part. Now, why was it unburnt at the center? If we look at the diagram, what is at the center? The almost colorless zone. Now, in the green-blue zone, you're going to have partial burning. Burning will still take place, but it's not going to be complete. And the reason for this comes back to the amount of air that is present. So, this part of the flame is not in contact with the surrounding atmosphere. So, there is air, but just not enough. So, burning will take place, but not complete. Now, the almost colorless zone is whereby burning does not take place. Because at this point, you don't have any supply of air at all. This is the innermost region. So this consists of unburnt gases. So the outermost region, the pale blue zone, is where you have complete burning. Green blue zone, partial burning. It takes place, but it's not as hot. And then the almost colorless zone, no burning at all. So the gases are just simply unburnt. And that is the reason why we are having the wooden splint as such. Now, coming back to our flame, remember I told you about the 2 flames? If I took another wooden splint and placed it at the very tip of the flame across where the pale blue zone is, what I'm going to see is this. I'm going to experience complete burning at the point where the wooden splint comes into contact with the pale blue zone. Why? Because at this zone, we have complete burning. So any part of the wooden splint that comes into contact with the pale blue zone is going to be completely burnt. And that is what happens. Moving on to question 14. Now, question 14 is similar to this, just a little bit different. Remember, I told you by the end of this session, chemistry imelala. The diagram below shows the appearance of two pieces of paper placed in different parts of a non-luminous flame over Bunsen burner and moved quickly before they caught fire. So in this case, we are still involving the non-luminous flame. Now look at the question. It's not going to tell you where the pieces of paper were placed. It's up to you to know, but it gives you a hint. It tells you that the pieces of paper were placed at different parts of the flame. So that means one was placed at the center and the other was placed at the very tip of the flame where the pale blue zone is. Okay, now let's look at this. So what happens here is that this piece of paper was placed at the center. So the parts of the paper that were burnt were those that came into contact with the hottest part of the flame, and that is the pale blue zone. The middle parts were unburnt. Why? Because at this point, you have gases that are completely unburnt, in the almost colorless zone. Now, in the second piece of paper, what happens is that you have complete charring, complete burning. Now, this was placed at the tip of the flame where the pale blue zone is. So at this point, you have complete burning of the gas taking place. So all the parts of the paper that came into contact with this part of the flame were uniformly burnt. And that is that. Moving on to our next subtopic, laboratory rules. So state 3 rules to be observed while in the chemistry lab. Now there are so many rules that are to be observed in the lab. In fact, there are more than 15. So whichever you choose is okay. Just ensure that what you choose is easy for you to remember. And whatever you write should be number 1, correctly written, and number 2, complete. Okay, let me give an example of this. Let's say you're using the rule, never run while in the lab, and you leave it at that. That is incomplete. State the reason why a student should never run in the lab. And the reason is because you may easily trip and injure yourself or even others. So another rule is always keep flammable substances away from flames. Why? Because they can easily catch fire and cause accidents. And the last one is always extinguish flames that are not in use. Now, this is for 2 reasons. Number 1 is to avoid fire accidents, and number 2 is to minimize fuel wastage. Now, I've seen questions whereby students are being asked, why should you as a student put out flames that are not being used? And these are the 2 reasons. Now, I'm going to explain why. Number 1, how are you avoiding the accidents? Now, when talking about accidents can easily happen, especially with the non-luminous flames. These are the flames that are pale blue in color, and they can be easily overseen by students. If you have a room that is brightly lit, it can be difficult to notice the pale blue color of the non-luminous flame. As such, it can easily cause accidents. Now, the second reason is so that you can reduce wastage of fuel. Now, what fuel am I talking about here? The laboratory gas that is being used by the Bunsen burner. So if you have a flame that is on and you're not using it, what is happening is that the gas is being continuously burnt up. It's being wasted for no reason. So these are the 2 reasons. But, by the way, use any of the rules that are easier for you to memorize. Next question. Set the laboratory rules that should be applied to prevent the following accidents. Okay. So we're going to go through the statements and find out what rule should have been applied to prevent the following accidents. So part A, mistaking hydrochloric acid to be distilled water. This. You should always label all the chemicals to prevent confusion. So it's easy for you to mistake hydrochloric acid for distilled water because they're both colorless. But if they had been correctly labeled, this confusion will not have happened. Part B, a student got burnt after secretly lighting up a magnesium ribbon. Emphasis is on the word secretly. So the student did this without the teacher's permission. So this goes back to the rule. Always consult your teacher before trying out any experiment to avoid accidents. Part C, a student got severe stomach ache after eating some bread during the chemistry laboratory session. I know this, and this is a rule that is often broken by students. So this is never test or eat anything in the lab to avoid poisoning.
And that brings us to the end of this part 1. So in part 1, as you may have noticed, we have been discussing introduction to chemistry only. And I hope by now content imelala. Now, in our next part of the video, we are going to discuss the second chapter. And that, of course, is simple classification of substances. Nakwambia, I've prepared so many beautiful questions for you, mutaiva. So be sure to check out the next part, and I'm going to see you there.